Hey, happy Easter. I would love to do a video on Easter, its meaning, significance, and how awesome God is and Jesus and the fulfilled promise and all that. Well, that's not going to be the episode today. It's just really going to be about a progress check for do quantum apex, however I want to refer to in the video. Um, Right now, we're in a stage where we have a research presentation by the end of the month. I want to say already start of May. And what we're trying to just wrap up everything. So, just for context, we're taking the global supply chain for plasma, like imagine a company like CSL. How can we optimize that with cubots, right? Because quadratic unconstrained binary optimization, and then using quantum annealers like think D-Wave, we use that to run it. So like if you have that plus CL cells pipeline, boom, a bunch of plasma being outputted. Really good for CSL, really good for the world because plasma is a very useful resource. So that's the goal there. So right now, what I'm working on is we just kind of figure out the baselines to compare it against, so I can say, okay, our Cuba's a process working really well, our Cuba's process not working really well. So I'm using a popular approach is MILP. I just realized I didn't know what the meaning was before this. Yeah, had a feeling it's mixed integer linear programming. So that's a popular approach for these companies. So we're just comparing against that. We're looking at other companies, see how can they be used as a baseline. The tricky thing though is you can't just have two approaches with different formats in the sense like I can't say this approach solves this problem and this approach solves a different problem and say, hey, let's compare them because apple and oranges. So it's really just figure out how do I get all both approaches to be to be running the same thing and then comparing them against one another. So that's really just a challenge right now, but nothing too crazy. Um, so that's pretty nice. There's another project. It's also on the NDA. It's not. I can't speak. That project is under NDA, so I can't really talk about it. But I can say it's really, really fun. I can say the pace of the team is really, really surprising. One thing I did with this team is since our first meeting was this week, I really think it's a really important project for Big Think AI overall. I really want to stress the importance of just being consistent, having motivation, being self-driven, stuff like that. So instead of like giving everyone their roles and saying, hey, you guys, you're going to work on this and you're going to work on this, I really said, hey, this is a problem. No one has really solved it. This weekend, everyone's going to work on this problem and figure out a way to solve it. So there's been about 2 to 3 approaches I've seen so far, and we're just building on one another's approach, right? I think it's a really great way to really just onboard people onto difficult problems. Because if I was to say this is your role and this is your role, it then becomes too compartmentalized too early on. I guess too specialized early on, and then people really don't have a understanding of what's really being done. But when your goal is to really tackle the whole elephant, right? Even though you're probably not going to figure out the answer, you do get good grasp of what's going on. Um, so I think I might do that approach for future teams. So even with like the AI Dungeon Dragons one, since it's not as hard of a problem, I'm debating should I use this approach? Like, should I just say, hey, everyone, try and build this by yourself? But I also do think since there's already a code base and this largely there the project is in a position where people can afford and it's probably better for them to specialize. I don't know if I want to take the same approach, but for future projects, that may be the approach I take. Um and yeah, I submitted, thank God, by the way, I submitted the workshop paper for OpenSum 3D at CVPR. So I submitted that a while ago. So I think the next workshop I'm going to submit to is in SIGGRAPH. SIGGRAPH has two workshops, or two, so I can submit to. One is like a student poster, and one is just like a workshop thing. So I'm going to submit to both, improve the work that's being done for those workshops. And the previous one was basically taking Gaussians as flesh and then using meshes as skin. So imagine Gaussians having states beyond just like the normal stuff like the anisotropic, I can't speak, matrices, like having actual like properties of matter. That's probably the best way to use explain it. And then using those properties of matter, you apply physics. So if I was to have, this is a bit too rigid for my example. Let's say this was elastic, or I guess if it was rigid, you would encode those properties into each Gaussian particle of this. And once that's the case, then it now allows you to have a dynamic scene. I can pick this up, I can throw it, it can interact with a rigid wall or elastic wall or fluid. The fluid is actually really tricky. Fluid is really, really tricky. I wonder if I should specialize in fluid real quick for the posters because fluid Gaussians would be really awesome to see to figure out how to do that because I haven't really seen a paper that does it really well. Even Omni Fish JS or Fizz Gaussian, I don't think they did it really well. I saw like the examples with liquid, and yeah, it's cool, but like that's not how liquid works, right? So maybe that's something I should look into. I don't want to spend too long on the this work though, because um because this is part of Star Labs. Star Labs is spatial temporal abstraction representation. And the whole reason I was even working on representations because for a world model, a representation is really important for like how does those world model actually create dynamic worlds you can interact with. But then I don't want to dedicate all my time to like the representation stuff because even though it's really is quintessential for the project in the lab, spatial is also really important because a world model needs to understand the spatial relationships just as a starter for a world model to work, right? So like how do if I was creating a bird flying through a plane, right? Like inside a plane, how would that even work? How would the chairs be seated and all that, how like the dynamics of that work. That's a complex scene. But like imagine that, imagine you think about it and now imagine training a computer to do that. So it's really difficult. I think GPA has been really interesting because at first I don't know why I was cocky. I dismissed it. I was like, oh, that's really the approach. But GPA or JPA, however you say it, is a really good approach to learn action dynamics. Maybe that's gonna be the approach. I've also been wondering if it's something where you have to combine multiple approaches. Like if I wanted to build a plane is really just it's it's an ellipsoid. I think that's the word. Like basically take a sphere. Yeah, ellipsoid, right? Take that, like, so maybe you can create, have like a geometric conformed neural network that's able to create like an ellipsoid, and from there, like, figure out logistics physically or physics wise using like physics informed neural network and stuff like that. So maybe that's the approach. Maybe you just combine everything into some Frankenstein monster, and now you have like the spatial problem figured out sort of. Maybe not. So that's something that'd be really interesting to figure out, and that's why I'm like debating how much I should spend on representation because representation is obviously a big thing, and it's even less. I would argue less AI stuff, like less machine learning, and more so I just actually figure out representation. Whereas spatial is much more machine learning, and does have much broader uses immediately, and feels like in robotics and other stuff. So that's something I'm debating now. But right now, I'm just sticking with the Gaussian stuff because representation is still important. But I also want to be learning about the spatial aspects which also feed into temporal and abstraction feeds into representation. Yeah. So that's pretty much where I am with that. Turp Mill is the last thing, the last org I'm really a part of. Stuff are going well there. Just we have to push the pace. I've decided that as a team, Terp Labs is a part. Terp Meals is a part of Terp Labs. Terp Labs is a student-run org that basically has a couple teams that create these student-run apps. Right now, I'm a project manager for Terp Meals, which is basically a meal personalization app. And what I've decided is that I'm just going to take the hiring process under our wing because it was originally under the Terp Labs team's wing. However, it's just been a real like hectic to figure out that because I think it's just too just too compartmentalized or like just too far off. And I think if we do, we can get the necessary people for the back end, which frees me up a bit to go do other stuff and work on more important decisions. I want to say. So I'm going to get that done. I think sometime this week, where I just figure out people to hire. Even with the first project I talked about with the NDA one, we have two people, we have two open positions. So I'm looking for some certain majors to fill out those positions. So it's also going to be a hiring week for me. So that's going to be really cool to see how that works. But besides that, I have nothing else to say. So have a great day.